All right, here I'll talk about the illumination-induced solute uptake in liquid crystal droplets. This is one of the findings recently in our group. It is related to the Cyanobiphenyl-type of the molecules. And it is fully deeply related to the Excimer excitation. Right? So here, at first, let's start from background and our work. So as you many of you know, that when the liquid crystal droplet in surfactant solution, it shows the various different motion, and which is induced by the Marangoni flow inside the liquid crystal droplet during the solubilization into the solution. And also some of the liquid crystal droplets, including the active protein molecules, actually shows a strange motion, but the motion type is controlled by the several numbers of the defects. And in our group, we've studied the photo-induced motion of the liquid crystalline droplets. And what we found is photoresponsive molecules move towards the light source by rolling on the substrate when the light is on. And also, we can even modify the droplet. It's moved away from the droplets when the light is on, and also moved towards the light source. This is simply by modifying the photoresponsive molecules of functional group, hydroxyl group, and methyl group. And this is controlled by the photo-induced change is induced the molecules towards the interface or the dissociated from the interfaces. And during this kind of research, we've found a very interesting phenomenon. And this is a liquid crystalline droplet, again, inside the surfactant solution, and also including the solute molecules, in this case, para-nitrophenol. When the light is illuminated, somehow the objects are formed inside the liquid crystal droplet, and they aggregate to the center of the topological defects of the liquid crystalline droplet. So what happened is a new creation at random place in the liquid crystalline droplet, and then they grew at the topological defect. And we suppose this is triggered by light irradiation. And then we tested several different types of the solute molecules like this. So we used the 365 nanometer UV LED. So these molecules absorb the light. So light absorption of the solute molecule is the key for the phenomenon we supposed. And we successfully prepared various kind of the aggregation inside the droplet. So this strategy is quite common for any types of molecules. But we found out the assumption of the light absorption of the solute molecules was simply mistaken. This is what we found. And so what was wrong with it? And this is quite deeply related to the Excimer state of cyanobiphenyl molecules. Here's the experiment we did. So we did a LC droplet inside the surfactant solution, including the solute molecules. However, we just tested without solute molecules and then concentration dependence of the surfactant molecules. Here's the result. So we found some object without solute molecules. So obviously, this could be SDS because this size is dependent on the SDS concentration. And then we checked the absorption of SDS solution, at 365 nanometer, but some light absorption there, but it's really very small. So is it really possible by this absorption? At this time, the Professor Ikeda, he's a pioneer researcher in the liquid crystal field. He's in our university, and he suggested very interesting things about Excima formation of the liquid crystal. Excima is the excited state of the associated molecules, not the monomer state. And this emit the light, and this Excima emission is around 390 nanometer. And so we checked this in old papers, and emission actually 390 nanometer, and then scanning the excitation wavelengths, we can get excitation spectra. And looking at the excitation spectra, actually it extended to the 360 nanometer. But when we check the absorption spectrum of 5CB in a conventional UV-based spectrum, totally no absorption over 300 nanometer. Of course, maybe it's detection limit. But looking at the photoluminescence by excitation of 365 nanometer, obviously there's some peak at 390 nanometer. So PL is observable even by minor absorption at 365 nanometer. Then we tested the PL excitation, observing the 390 nanometer and then scanning the pump light. It seems almost nothing, but taking the logarithmic scale, it's kind of actually extended to this wavelength region. But at the same time, in this case, if this is true, 320 nanometer in the more UV region is appropriate for excitation of the Excima state. Then we tested the UV light wavelengths from 365 nanometer to 320 nanometer, even though the intensity is much, much lower. But after 10 minutes illumination, in the case of 365 nanometer, nothing happened, but 320 nanometer, we can see the object inside. So even though the intensities are 10 times weaker, the objects were formed. So we tested for various different surfactant molecules. And in the case of water, nothing observed, but SDS, CTAB, DTAB, twin 20, PBA, in every case, we can see some of the objects. So all the surfactant molecules are taken into the liquid crystal droplets. And during this process, so we checked the Excima peak at the PL. In the water case is this one. And when some surfactant molecules or solute molecules are there, 5CB Excima peak was actually reduced. So it seems like Excima energy is consumed. So we tested the concentration dependence of the SDS concentration and making the Stern-Volmer probe. It showed a clear linear relationship. So Excima energy is obviously used by the surfactant molecules. So what we suppose that is Excima is excited and then associated with the surfactant molecules, somehow using the Excima excitation energy, take these molecules inside the liquid crystal droplet and making the aggregations. So, and then we tested for various molecules in this case, and we tested in this case colored larger molecules. What we found here is, in some cases, we can find the object inside, and in some cases, nothing there. So what happened here? Again, we examined the photoluminescence of Excima. So this is a water case. And when we observe the object inside, it's actually the PL intensity was reduced, and then the excimer energy has been used. However, when the nothing was formed case, all the dyes, the eczema peak was originally not observed. It means eczema itself is disturbed for formation when these kind of dyes are included. Right? So this also supports our assumption. And one of the interesting application in the case of using the rhodamin B, and then this is water-soluble molecules, and then try to aggregate inside the liquid crystalline droplets, and by monitoring the single particle fluorescence molecules, fluorescence. So this is after 60 minutes radiation inside the rhodamin B solution. We can recognize various objects inside the droplet. And when we observe inside the liquid crystal droplet, actually this fluorescence peak gradually increased. So it's interestingly, even the water-soluble dye can be incorporated into the LC droplet by using this method. So finally, I will show another interesting phenomena recently found related to the eczema state. So what we did previously is a UV light is illuminated to the liquid crystalline droplet in the surfactant solution over the CMC concentration. And we tested for various different concentrations. And what we originally found was somehow aggregated to the center of the liquid crystalline droplet. However, when the concentration is much lower, what happened here is like this. It's actually expanded. So some expansion happened under some conditions. So we tested various surfactant solution by different the concentrations and then different solution. Right. So what we did is a different surfactant solution with different concentration. So what we found in the case of C14 tab case, so for the concentration higher, we observe this kind of the object formation inside. But if it's lower, the concentration actually expanded. So expansion happened on some surfactant concentration. And they also, in the case of C18 tab, for the higher concentration, again, we can see some object formation inside. But in the lower concentration, that's very interesting. So it start expand, but it's dissociate into the different the two droplets. So expansion and dissociation observed for C18 tau. So what happened here is there's some concentration threshold. We observe the expansion and solute uptake. So this is the corresponding concentration for what we observed. The phenomena has been modified. So this concentration is very much close to the CMC concentration, actually. So below the CMC and then above the CMC is the difference. The surfactant molecules inside the solution is monomer or the micellar condition. And for this kind of observation, the monomer conditions are important. And also we confirmed what was included inside by the light illumination by using the Raman microscopy. So we can test before and after if the Raman spectrum was confirmed inside, and we could clearly observe the water stretching band enhanced after the expansion. So, but without expansion condition, we didn't see any increase of this. So droplets uptake happened under this expansion condition. So what we observed here is below the CMC concentration, we suppose the surfactants molecules are made of the hydrophilic and hydrophobic parts, and the hydrophobic parts were hydrated due to the hydrophobic hydration inside the solution. So water is together there. So when the eczema is excited and somehow take the molecules inside, this water is coming together inside the solution, inside the droplet. That's why the droplet expanded. But above the CMC concentration, the surfactants molecules are in the state of micellar condition. So even though they were taken inside, no water is taken into. So here's the summary, and the first part of the Solute uptake was published last year, and the following one has not been published yet. Right? So with that, that's the all of my consent, the presentation.